as I was saying in the previous video, and then I was cut off, we'll focus on calculations on Monday, but a little bit more into depth about why fuels or how reactions are occurring. So what happens is we're assuming that all of these carbons and hydrogen interactions are broken. And then these interactions between the two oxygens are broken. You have some free oxygens and free carbons and free hydrogens just hanging out, and there's the attraction between the carbon and oxygen is greater than that of just the carbon hydrogens together. So the carbon oxygen double bonds are stronger than the carbon hydrogen bonds and between the oxygen oxygen bonds. So in this reaction, it is more favorable to break these bonds and form new products. This is not always the case. Okay? Some reactants don't want to break up and don't want to react, so no reactions occur. And we can measure quantitatively if reactions are going to occur and what kind of energetics to expect. So enthalpy is extensive. So if you guys remember back from one of the first chapters, that means it depends on how much it has. So it is dependent on the moles. So depending on how many moles of your reactants and how many moles of your products, that will change your delta H of reaction. So again, we are measuring the delta, so the change in enthalpies, change of the products minus change of the reactants. We also have taken count the moles. Okay, so in this case, nitrogen to hydrogen to ammonia, there is a 1:3 ratio between hydrogens or nitrogens and hydrogens, and a 1:2 ratio between the nitrogen and ammonia. And we'll show you how to do that. And this double arrow, do you guys remember that from a weak acids, weak base? That means it's at equilibrium. So at any point, the reaction should be going forward or in the reverse. So that means you learn something about the delta H. So the delta H of the forward reaction has to equal the delta H of the reverse reaction, but just with a different sign. So your delta H of the whole reaction is going to be the same whether you're going forward or backwards. The sign will just change. And it is dependent, and one of the things that confuses people is that it depends on the state of the products and the state of reactants. This should say reactants, not reactions. So whether you have a gaseous system versus a liquid versus a solid, that's going to change your delta H. So the delta H of reaction for water, whether you're forming gas, solid, or liquid, is going to give you a different delta H. And so on Monday, we'll learn how to calculate it. Chapter 6 homework is open. Chapter 9 will be should be finished, and you should be doing the quiz, and the homework should be completed. Okay. Please email me if you have any questions. We will be moving to chapter 18 next week, so it is getting a little bit faster. Okay. Have a great day, and don't forget to take the quiz for this video.